Welcome to section 11.3. We are dealing with what we call a normal distribution, and we're going to talk a little bit about bell curves and things like that. So here we go. Oh. Okay, taking a look, we're going to give you the frame, and we want to start with what are we even talking about. We're going to be looking at this idea of your standard deviation, and we did standard deviations in 11.1 and 11.2, and we talked about basically how far away from the mean does the data lie. We're going to put it in terms of a normal distribution, which means we'll have a curve in order to fit that. So that's the first main idea that we're talking about. Now, let's take a look. As we do this, we want to look at the fact that a normal distribution is modeled by a bell curve. Okay, we call it a normal curve because it's symmetric about the mean, okay, or the average if you want to call it that. We know that the mean is represented with an x and a bar over top, so x bar. And the standard deviation, we said, had this symbol for sigma. Okay? Now, there are a few main ideas that we need to know about talking about a normal distribution. The first idea is that the area under the curve is considered the percentage of the data, and we're talking about percent of data. The total area under the curve makes up 100%. And that's important because when we look at this curve, we're talking about 100% of the data. Now, about 68% lies within one standard deviation of the mean. And I'm going to give you a visual for that in just a second. 95% of the data, let's do a percent sign, lies within two standard deviations of the mean. And 99.7% of the data lies within three standard deviations of the mean. Okay, and so kind of as we go through, again, I will show you this visual in just a minute and kind of give you a hint as to what I'm looking for. But if you take a look, this is the idea that you have this visual where basically one standard deviation, you can go in the positive direction or the negative direction. And what I want to do is I want to draw this a little bigger for you, and I want to really dig in and explain what in the heck this means. Okay, now, in the middle of our normal curve is always the average or the mean. We said the standard deviation helps us break down our data and tells us basically how far the majority of our data lies from the mean. Well, if I go to the right one standard deviation, the way we write this is the mean plus one standard deviation. If I move to the right two standard deviations, we say the mean plus two standard deviations. And 3 lines out is the mean plus 3 standard deviations. Okay, now it works the same way in the other direction. One value to the left is the mean minus 1 standard deviation. 2 lines to the left is the mean minus 2 standard deviations. And the third line on the left is the mean minus 3 standard deviations. Now you only go out 3 standard deviations in each direction when we're talking about a normal curve. Okay, so what we said is within one standard deviation, so from this line to this line, it makes up 68% of the data, and that's what this is talking about here. If I go 2 lines, I get 95% of the data, and 3 lines gets us 99.7% of the data. The only problem is I don't like knowing those 3 values. I'd rather know this with this second graph, and this is the one I want you to know. I don't want you to memorize this one, because we're going to start breaking this apart into each section anyways as we go, so why would I learn the 2 parts when I could just learn 1? So here's what I want you to know. One standard deviation is 34%. The second standard deviation is 13.5%. The third standard deviation is 2.35%. And all of that little itty bitty leftover is 0.15%. And this is what I want you to kind of keep in mind. So let's look at the example they give you. They ask you to find from the mean to the third standard deviation. So this is from the mean to the third deviation, and it's positive because I'm going plus. So the way I'm going to look at it is, here's my mean, here's my third deviation, and they want you to add up the percentage in between. So I want to know what's the percent that all of this occurs. Well, which percentages then do I add up? Well, I add up the 34, the 13.5, and the 2.35. And so if I add that up, 34 plus 13.5 plus 2.35, what I end up getting is 49.85%. And we're looking at it, basically, we look, if my normal curve is split in half, this side would be 50% of my data, and this side would be 50% of my data. So do I really have all 50%? No, I'm missing this little extra piece. If you wanted, couldn't you have said 50% minus 0.15%? Sure, you would have gotten the same thing. So you can look at it in two different ways, but I really like to look at it in terms of where's it starting and where's it ending. And then I just have to show adding up the percentages as you go. One thing I'm going to ask you in the quiz is that you show me your normal curve and you shade in whatever regions you're trying to add together. So let's try a couple more. Now we give you 4 of them here, and we're going to kind of look at kind of easier ways to look at them and harder. Here's what I look at first. I would like to do number 2, let's label these. Here's number 1, number 2, number 3, and number 4. I want to actually do 2 and 3 first because I think those are easier. They give you a starting point and an ending point because there are 2 inequalities. So I start at the mean, which is the middle line, and I go out 2 standard deviations to the right. So I count 2 lines to the right, and this is where I end. So what I want you to do is shade in what we're looking for. And now let's talk about what percentages we have to add up. Well, this first one is 34%. Let's just cross that off, 34%. The second one is my 13.5%. And so if I add those together, I get 47.5%. Okay, so let's try the third one. They give me a starting, because I have 2 inequalities, I know where I start. This says 1 to the left. So I'm going to go from the mean, I go 1 to the left, that's where I'm going to start. I'm going to end at the mean. So I just want this mean bar, so I want everything in the middle. Well, the percentages on this side are the same as the percentages on this side, so it's just 34%. Pretty nice and easy. Now let's go back to number 1, because number 1 doesn't tell us a start and an ending point. What they're saying is we want the value, we want the mean to be less than everything I'm looking for. So I'm basically looking less than the mean is what they're basically asking. Okay, so as I go through, and you know what, yours looks different than mine actually as I'm looking at this, so let me change this for you. This actually should say x is less than or equal to x bar the mean. And I apologize because that's what it should be looking like, because we want x to be less than the mean. And I don't know why yours came up differently, but let's look. Here's my mean, and I want everything less than. So I want all of this stuff down here. Now, if you look at it, you know this is 50%, right? Because it's half of my curve. But let's talk about how we get that. We add the 34% for the big one, plus the 13.5% for the second one, plus the 2.35% for the third one, and the 0.15% for the last one. Okay? Now, obviously, if you shade half of it, I know it's half of it. You may not have to show that work, but you still, again, should know that that does equal 50%. All right, let's try one more. As we look at this, this says find the value greater than or equal to the mean plus 1 standard deviation. So the mean plus 1 is 1 to the right, and I want everything greater than that line. So I'm going to look for this stuff. So what percentages am I adding up? This first one is 13.5. The second one is 2.35, and the third one is 0.15%. Therefore, we get 16%. Okay? Once you know the percentages and kind of what the question is asking, this ends up being really nice. So what we're going to do is kind of flip the page and kind of look at some more options as to why we use this normal curve. Okay, so let me give you one reason why we use the normal curve. SAT scores normally give an average or a mean, and then they tell you how far away the next percentage of data is. And if you look, they tell you the mean is 518, the standard deviation is 114. Now this example has been really, really nice to actually set this up for you, but normally you're going to have to set this up for yourself. We put the mean in the middle bar. Okay, in order to get one deviation to the right, I'm going to add 114. To get two deviations to the right, I'm going to add a second 114. To get to three deviations to the right, I'm going to add a third 114. Okay, to get one deviation to the left, I'm going to subtract 114. To get two deviations to the left, I'm going to subtract a second 114. And to get three deviations to the left, I'm going to subtract a third 114. And so I want you to kind of see how that works, because I am going to give you examples where you're going to have to do that by yourself. Now, we have now values for these deviations. The question is, can we find the percent between 518 and 746? Okay, well 518 is here, 746 is here. The question is, because these are at actual standard deviations, all I have to do is add the percents 34 and 13.5. And if I add 34 and 13.5, I end up getting 47.5%. And that's really nice. Now let's look at the next one. What percentage scored less than 404? Well, 404 is here, and if I want less than, I'm adding up 13.5, 2.35, and 0.15%. And if I add up those three percentages, I end up getting 16%. Okay, now again, there are going to be times when we are going to ask you to actually write the values at the bottom of the normal curve. And so if you still don't quite understand how those work, please let me know. Now this is really nice when we ask you scores between specific numbers that are actually standard deviations. The problem is that is rare for it to happen. Okay, so what happens if it doesn't? Well, if it doesn't, then we give you this idea of what we call a standard normal table. And if it's standard, then we're going to give you a mean of 0. And our standard deviation is 1. And we're going to make it work that way basically by creating what we call a z-score so that we can kind of shift our normal curve to be able to work no matter what situation we have. So here's what happens. You get a normal distribution with a basic mean and standard deviation. But because we know this, it's not centered in the right place, so we're going to move it to a mean of 0 and a standard deviation of 1. Now this formula right here, you have to memorize. I'm not giving you that formula. What I will give you is I will give you the table. Okay, absolutely any single thing I'm going to ask you to do, I do not expect you to remember that. And so I will absolutely show you how that works. Now, keep this table handy because we're going to work on this. Now, here's what happens. We're going to use this formula and get a score. And let's say we get an answer. You always round to the nearest tenth. Let's say we get an answer of 2.4. Okay? What we're going to do is go over to the 2 and then over to 0.4. This is the percent of people for whatever that situation that lies underneath the curve. So 99.18% of the data is underneath that curve. And so this is kind of what's happening. And let's give you a couple examples. Here's what happens. As I look at this, I give you a survey of women that the height is normally an average of 64.5 inches, a standard deviation of 2.5 inches. Okay, so here's what we're going to do. I'm going to write this really big for a second because we're going to have to fill some things in. We know our average is 64.5 inches. Each deviation is 2.5 inches. So if I go one deviation to the right, I'm going to add 2.5 and get 67. To get two deviations, I'm going to add another 2.5 to get 69.5. To add three deviations, I'm going to add another 2.5 and I'm going to get 72. Okay? So to go back one deviation, I'm going to subtract 2.5, you get 62. To go back two deviations, I'm going to do another 2.5, so 59.5. And if I go to three deviations to go back, I end up getting 57. Okay, now, the reason I do this first is because some of the time they're going to ask me things about these exact standard deviations. And really, let's take a look to start. If I look at this fourth one, 72 is a number that's directly on my standard deviation. And because of that, I can use my percentages. So they want to know greater than or equal to 72. So I'm really looking at this area right here. Well, I don't need to add anything. I know that's 0.15%. So do I have any extra work to do? Not a darn thing, which is what we like. The problem occurs when the values they're asking us for don't occur on the normal curve. And since they're not on the normal curve, we have to go back to this idea of a z-score. And our z-score formula was the value they want minus the mean all over the standard deviation. Okay, again, that's something you have to know. So we take a z-score for the first one. We know 58 is like here-ish, right? And I want to know everything less than 58. So I can assume it's going to be under this 2.35%. I just don't know where. So here's what we're going to do. We're going to take a z-score. If I start with a z-score, I take 58 minus my mean, and my mean was 64.5. And I'm going to divide it by my standard deviation, which was 2.5. If you're doing it in one swoop of a motion, please make sure you put parentheses. Okay, so I stick this in, and what I get a z-score is negative 2.6. Now, z-scores always talk about, maybe that's something I should also say, the table only works for less than. And I'll show you how to do it if it's not, but it only works for less than. And so what I do is I go to negative 2 and over to 0.6. And what it gives me is 0.0047. So I get 0.0047. We want you to put it in a percentage. So if I move my decimal place 2, I get 0.47%. Oh, I apologize. So take your answer and put it back as a percentage. So I'm using my table. That's the big idea. Now in this case, let me just go back here. If I did a z-score for the fourth one, I want to show you how it works because the table's a little deceiving, so I want to talk about the table. My z-score would be 72 minus my mean all over my standard deviation. And what I'd end up getting is 3.0. And so I'd go to 3, positive 3.0, and I get 0.9987. And this is, again, an approximation. Now, because my table says less than, I need the complement of greater than. So what I would do is 1 minus whatever I got at 0.30. So 1 minus 0.9987. And you would end up getting 0.0013, which is about 0.13%. Now these are slightly off. 0.02 is minimal to me. In this case, I would have gone immediately to my normal curve and used percentages. But again, the table is a helpful approximation. Maybe not exact, but a helpful approximation. And so if you would have done either way, 1 minus or just look at the percentages, I would have taken either of those scores. But here's the idea. If it's greater than, you have to do the complement. Okay, so if it's greater than, the complement has to come into play. Okay, let's try one more. Here it's saying between two values. And the way it works is I'm going to look from 72 all the way down, and then from 65 all the way down, and I'm going to subtract the overlap that I did. So what I'm going to do is I'm going to take the z-score, the probability at 72, and I'm going to subtract the probability at 65. Now in order to do that, I need a z-score for both of them. So I'm going to do a little work. The z-score for, I'm going to start 72, is 72 minus 64.5, all divided by 2.5, and we said you got 3.0. Okay, so I do the z-score for 65, 65 minus 64.5, all over 2.5. I get a z-score of 0.2. And again, you're always rounding to the nearest 10. So what I do is I go to my table at 3, and at 3 I get 0.9987, and I subtract the value at 0.2. Now because it's a positive 0, I use the positive 0. 0.012, I use 0.5793. And when I subtract these two, you end up getting 0.4194. Put it in a percentage, 41.94%. Okay? Now what I'm going to have you do is this one. I want you to do on your own. And you're basically following the same thing as we did in the second one, but I want that one done on your own so that when you come to class, you know what's going on. So this is the idea with a normal curve. Again, if your values do not fall directly on a standard deviation, then you can't use the 34% or the 13% or any of those. You have to make a z-score and then come to the table. And so that's it for section 11.3. We're going to give you a warm-up in class tomorrow and talk about how this works. And we'll go through a couple examples. But if you can't, okay, this has to be done on your own. And if possible, start the homework.